So I've been experimenting with marshmallows. So what was my purpose behind experimenting with marshmallows? Basically, I wanted to see if I could find a statistical difference between the deflation times of different shapes of marshmallows. So my null hypothesis then would be that there would be no statistical difference between the variation times and the various shapes of marshmallows. In order to conduct this experiment, I used obviously different types of marshmallows, Hershey's bars, graham crackers, a microwave, and a stopwatch. Now obviously I didn't have to use Hershey's bars or graham crackers to inflate a marshmallow in a microwave, but they did add a nice little perk. So let me show you the experimental procedures. I have a video on this, but for some reason I'm back up. To conduct this marshmallow experiment, you'll need various types of marshmallows. For example, I have ghosts, pumpkins, and bats, since it is so close to Halloween. And bats and ghosts. And you basically take one of the marshmallows to make a s'more. You're going to place it into the microwave for 30 seconds. Have your stopwatch handy, and as soon as the 30 seconds is up and you hear the beep of the microwave, hit start on your stopwatch. Quickly pull the s'more out and watch it deflate. When the deflation is over, when there is no more movement taking place with the marshmallow, hit the stop button on your stopwatch. And you will repeat these procedures several times until you have got deflation times for all of your marshmallows. This is a pretty simple procedure and it doesn't take long at all. You're done. And let me just say, as far as the video goes, that's as good as it got, because in one of the videos, Luke has his chair and is doing this, and all you can hear is across the floor. So, moving on to the experiment. After I repeated these procedures 18 times, because I used 18 different marshmallows, I then organized my data into a table and found the averages of each deflation time for each marshmallow. Then I took those averages and made a bar graph. And the reason that I made this bar graph was because I wanted to add error bars, the standard deviation error bars, to see if there was in fact a normal distribution taking place. And I know that it's hard to see with the bats, but they do actually go up into the first standard deviation error bar, and so there is a normal distribution. And from this, I decided that I wanted to do an ANOVA test. And if you all don't know what an ANOVA test is, basically it lets you test the means for equality using 2 or more means. Where a t-test, I would have to do 3 individual tests. With ANOVA, I can test all my means at one time. So, also I went to YouTube and found a nice little video like how to do ANOVA, and it was really simple. You click this box, you select this row of data and hit enter, and boom, this is what you get. And if you're like me and you see this, you think, okay, what am I looking at? So I just want to briefly show you all what's going on with all this information. First, it says ANOVA single factor. It's single factor because I'm only dealing with one factor, and that is the deflation, the average deflation times of the different types of marshmallows. This box is obviously pretty explanatory. You have your groups and how many marshmallows are in each group, your means, and so on. This down here is where it kind of gets a little fuzzy if you don't know what you're looking at. So basically we have 2 sources of variation. And we're dealing with variation because in ANOVA it is the analysis of variance. And you have your variance between groups and your variance within your groups. And you have different calculations within these 2 categories. And these calculations are really important because they help lead up to or calculate, so to speak, your F value, which is a very important value. How many of you all worked with a t-test or maybe working with t-test? Show of hands. So you know that your t value or your t statistic is really important, right, in your t-test? Okay, it's the same one for your F value. Basically, we compare the F value to the F critical value, and if your F value is higher, which in this case it is, to the F critical, you can say that there is a statistical difference between your means. So in this case, I can say that there is a statistical difference between the average deflation times of the marshmallows. And I can also look at my p-value and see that it is in fact less than my alpha, which was 0.05. Okay, let me go back and state that even though this test shows me that there is a statistical difference, it doesn't tell me where that statistical difference is. So, to better explain, I have 3 pictures, and I have 3 different pairs of marshmallows. We know that there's a statistical difference, but we don't know if there's a statistical difference between the means of all 3 pairs, or there could only be a statistical difference between 1 pair. This is where the t-test comes into play. So, basically, if you do an ANOVA test and you find that there's a difference, then you'll have to break it down into individual t-tests to see where that difference takes place. So the first t-test, we have the pumpkin and the ghost. And you can see that there is no statistical difference between the average variation or the average deflation times of the pumpkin and the ghost, because the t-value is less than the t-critical value. And you can also see similar results between the pumpkin and the bat. But when I tested the average deflation time of the ghost and the bat, this is where that I saw my statistical difference of the means. And the ghost is actually the marshmallow that took the longest to deflate, and the bat was the marshmallow that took the shortest time to deflate. So, based on the ANOVA test and based on my t-test, I can say that there is in fact a statistical difference, and I can reject my null hypothesis. Now, some of you all may be thinking, so why in the world would you choose to do ANOVA when you're going to have to do t-test? Well, that's not always the case, because say, for example, you were going to test 6 different means, and you chose to do 6 individual t-tests, and after you analyzed your data, you saw that there was no statistical differences between your means. Well, you could have found all that with using one simple ANOVA test and came to the same conclusion. And anybody have any questions?
Go to Katie first. I'll let.
Okay. Whenever you were first showing the ANOVA thing, you had your p-value, and it was like 0.01. I lost it. I lost where I was going with that.
Okay.
Go ahead, Mr.
Okay, I have 3 questions.
Okay.
Question number 1, why did, you were correct, but what led you to know that you should use a 2-tailed t-test?
Well, basically, I went on YouTube again and watched a lot of different, like, people using ANOVA, and the 2-tailed, it said the 1 tail is if you're looking like at one specific.
You're getting there. Come, keep on.
The 1 tail is if you're looking like at one specific thing. I guess maybe like which one deflates the fastest or which one deflates the shortest amount of time. But that's not what I was looking at. I was just looking at the overall.
Okay.
deflation rate.
I want you to go back and reconsider what you said in error. You said if you had 6 different things, you'd have to do 6 different t-tests. I don't believe that's accurate. You had 3 things, and you had to do 3 t-tests because you'd have to compare 1 and 2, 1 and 3, and 2 and 3. Think about it. If you had 6
You have
things,
to do a whole lot more.
do you have any idea how many you'd have to do?
36.
That's a good
That's
good
all.
guess. Let's open it up to the floor. How many would you have to do?
Wait, what?
If she had six different variables, how many t-tests would she have to do?
Like 21.
Not 21.
6 factorial?
Say it again?
6 factorial?
Not that many, thank God.
Factorial?
It's the factorial version
Oh,
of
the
add.
plus, yeah,
Yeah.
sorry, the
Yeah.
plussing of the factorial, whatever that is.
Okay.
6 plus 5 plus 1 plus 3
25.
plus 2 plus
No, 15, sorry.
38?
15.
Okay, it is 15, Robert, why is it 15?
Because it's 5 plus 4 plus 3 plus 2 plus 1.
Why is it 5 plus 4 plus 3 plus 2 plus 1?
Because you have 6 different groups, therefore that you're not gonna repeat groups, is it NCR,
It is an NCR, and that,
combination.
yeah, that's good because combinations are now a 7th grade objective, so it is good to know that that's 6C2. 6C2. Now, here's my last question. Go back to your chart with the error bars on. And explain to us what all that means. I'm not sure I know what it means.
Well, when we were doing the M&Ms, me and Tracy were working together, and we were told like to create a bar graph and then use your standard deviation error bars to see like if those bars fell within those standard deviations.
Okay, what I'm curious about, I understand that the BATS column is the average number of seconds of deflation for the bats and similarly for the ghost and pumpkin. But I noticed that all of the bars are the same. Where did that come from? Because all the bars that I'm seeing are exactly the same at the top and the bottom. So where did those come from?
Because like wouldn't your middle be your overall mean, like in your bell-shaped curve? And then the two ends would be like both sides of your standard deviation. Does that make sense?
Robert, you have a thought?
Well, I think I know what she did. She took the mean of all of them and then took the standard deviation.
It's the first
of
standard
all
deviation of the overall mean.
of the
between three
overall mean
groups.
of all of them.
Not the first standard deviation between just the bats and just the ghost and just the pumpkin.
Okay, so what does that picture tell us?
That they all fall within the standard deviation of
The
the
overall.
overall mean.
That's the way I would know.
Okay. Do you find that graph is very instructive?
I guess not.
I mean, I guess what I'm saying is if you found that to be very instructive, you might not need to have gone on any further, you know. I was just confused by what it was telling me. Okay, I'm done.
Well, actually, I have a question to ask you. I was gonna-
Please ask.
I read on the internet that if you chose to do multiple t-tests versus an ANOVA, that you're more likely to create a type 1 error.
That's correct.
Like, why would that be? Is there just more room for error? Or,
Well, the thing is, if you do one ANOVA and it turns out not to be statistically significant, then, well, first of all, you've saved a bunch of time, right? Okay, so every time that you do a t-test, you're coming up with a different possibility of making a type 1 error. Add all those together, look what's happening to your probability. I mean, it's blowing up. So not only is it a time saver, but it's an error saver too.
any more questions?
How many marshmallows did you eat?
Did I eat?
Did you eat like all these?
How many did you
Somebody
serve?
help.
Yeah, that was your helper, okay.
Yes, Tracy?
Do you have to have a minimum number of samples to run t-tests like 30? And if it's less, do you do an F-test?
You need to have a minimum number before you put much stock in it.
So if she had 18 per group, right? So the total of that is much more than 30.
Mhm.
So she would be okay because it's 18, 18, 18?
I had 18 marshmallows total. I didn't have 18.
So you
Oh,
had
total.
6 per group.
Yeah.
6
Oh,
per
you
group.
had 6 per
So
group.
you're comparing the average of 2 6 sample groups.
I
And,
thought- I'm
and
sorry.
certainly I understand what you're saying. For us to really say there's a lot of statistical significance, that's probably not a large enough sample, but we didn't want her to be microwaving from now into oblivion. So, you know, now if she wanted to have something published, then we'd want to take this and replicate it. We need to have you a whole test kitchen full of microwaves to do this. But yeah, you're exactly right. That 6 of each probably isn't enough to be able to
I'm just making sure, because I did something similar on mine, and I didn't know if there was a set rule or if what, so.
30 is just kind of a rule of thumb.